Right folks, welcome to our video on arithmetic sequences. We're going to be looking at describing what it means to have an arithmetic sequence, looking at some examples of sequences that are arithmetic and some that aren't, and also looking at finding the terms of a sequence. So, sequence then, normally just a list of numbers that has some general rule about how to find each of those terms. So a sequence, as you can see here, is arithmetic if it increases or decreases by the same amount. So as you go from one term to the next, the increase is the same or the decrease is the same. First example then, 2, 5, 8, 11 and 14. Well, if we look at this example, we can see from 2 to 5, we've got an increase of 3. From 5 to 8, we've also got an increase of 3. And similarly for 8 to 11, increase of 3, and 11 to 14, we're adding 3. So because we're adding the same number each time, this sequence is arithmetic. Our next example then, 4, 0, 4, 0, 4. So there's a pattern to this sequence. It goes 4, then 0. So to find the next one, you sort of look at the previous one. Is it 4 or 0? You swap it. But if we look at what the sequence increases or decreases by, well, 4 to 0, that's a decrease of 4. 0 to 4 is an increase of 4, and so on. 4 to 0, again, a decrease of 4, and 0 to 4 is an increase of 4. So because we are decreasing and increasing, this makes it not an arithmetic sequence. I know the number's the same, the 4 is the same each time, but it's decreasing then increasing, decreasing then increasing. It's not an arithmetic sequence. Right, 17, 10, 3 and minus 4. So this sequence is actually decreasing, but is it decreasing by the same amount each time? 17 to 10, well, that's a decrease of 7. 10 to 3, also a decrease of 7. And 3 to minus 4, got to be careful, we're going to negative numbers. Well, it's a decrease of 3 to get to 0, 4 more to get from 0 to minus 4 is also a decrease of 7. That is an arithmetic sequence. The decrease is the same each time. So 3 examples there, 2 that are arithmetic sequences and 1 that isn't. Right then, next we are going to look at finding terms in a sequence. So if we have a question like this, find the first 5 terms of the sequence with the nth term 5n plus 1. So 5n plus 1 is our nth term of the sequence. If you need to know how to find that for a question, look at the other video on the channel. 5n plus 1. Well, to find the first term then, we replace that n with a 1. So the first term, that's when n is equal to 1. So we do 5 times 1, add on the 1 from the nth term. 5 times 1 is 5, add on the 1, and we get 6. So 6 is our first term. Second term, we're going to replace n with 2 this time. N is equal to 2. Well, 5 times 2, add on the 1. 5 times 2 is 10, add on the 1, we get 11. 11 is our second term. Okay, third term then, we replace n with 3. So we do 5 times 3 plus 1, which is 15, plus 1, we get 16. 16 is our third term. Now at this point you can carry on, you can put n as 4, n as 5 to find the fourth and fifth term. You might though at this point then start spotting the pattern and saying, well, to get from 6 to 11 I increased by 5. To get from 11 to 16 I increased by 5. So if I do the same to the 16, increase that by 5, we get 21. And the last one, the fifth term, we increase 21 by 5 and we get 26. So there we have the first 5 terms of the sequence with the nth term 5n plus 1. Okay, I'd recommend going through the first at least 3, then you can spot the pattern from there. Okay, you may even wish to check. I'll tell you what, let's do one quick check, see if that 26 is correct. That would be the 5th term, which means you're replacing n with 5. So if n is equal to 5, 5n plus 1 we do 5 times 5, add the 1, which is 25, add 1, 26. So that pattern, spotting that pattern, using that to carry on the sequence, did work. That's fine. Right, one more example of that then. We're going to find the first 5 terms of the sequence with the nth term 3n minus 7 this time. Well, let's go for it again. Let's find the first term. That's when n is equal to 1. 3 times 1, replacing that n with a 1, 3 times n. 3 times 1, take away 7. Well, 3 times 1 is 3. Take away 7, going to become negative. We get minus 4. Minus 4 is our first term. Second term. Again, n equals 2, our second term. So we're doing 3 times 2, still taking away that 7. Every single time in this question we're taking away that 7 at the end. 3 times 2 is 6, take away 7, we get minus 1. 4 minus 1, our second term. We'll do the third and we'll see if we can spot the pattern. Third term, that's when n is equal to 3 because it's the third term. So 3 times 3 because n is 3. Always taking away that 7 in this question. 3 times 3 is 9. Take away 7 is 2. Apologies if you can't see what I'm writing because I'm left-handed. It's unfortunate. 2 then, our third term. Well, what's the pattern here then? From 4 to minus 1. 4 to minus 1, what are we doing? We are adding 3. From minus 1 to 2, we're adding 3. Let's carry on that same pattern, adding 3 each time. 2 add 3 is 5. 5 add 3 is 8. There's our first 5 terms. Again, then we'll just check that 8. So we'll find the 5th term and check that we did it correctly. The 5th term then, when n equals 5, 3 times 5, take away 7, or 3 times 5, 15, take away 7, we get the 8 we were looking for. We've done it correctly. Okay, so you can go through replacing all the numbers, could do 4 as well, or you could do the first 3 and spot the pattern from there. That will work. Right, one last question then, a bit of a bonus question. Find the 20th term of the sequence with the nth term 2n plus 3. Well, it's the 20th term that we're trying to find, and we have our nth term. This can find us any term in the sequence, but like a key. This is the key. We can unlock the door to any term in the sequence. Well, if find the 20th term, similar to before then, we're going to replace n with 20 this time. 20th term, n is equal to 20. So 2 times 20, 2 times n, add on the 3. Well, 2 times 20 is 40, add on that 3, and we get 43. Okay, a lot quicker then than just finding, like before, the first 5 terms and keep on adding 2 each time it would be in this case. Okay, right, that will conclude our introduction to sequences. Hopefully this helps you answer the questions, any questions you have or any questions you have been set. Don't forget to like, comment and subscribe. I'll see you next time.